Hello everyone, welcome back to Math Academy. Today in this video I am going to cover another section in the chapter logarithm that we have already started in the previous video. So in this video I am going to cover only laws and rules of logarithm. So the topics I will cover here: laws of logarithms and change of base rule. If required, please refer back to review the previous video on logarithm with a title Math Logarithm Introduction, which is already posted to understand clearly the foundational knowledge in this chapter. For example, definition, types, common logarithm and natural logarithm, etc. So if needed, please refer back to the previous video. That's how you can understand clearly in this video. Now let's see laws of logarithm. Why? Before we start anything in this topic, let's have a close look on the following. If there is a question like prove log 6 to the base 10 equal to log 3 to the base 10 plus log 2 to the base 10 log 1 to the base 10, how can we prove that? Let's see which solution is correct below. Suppose there is one solution here. Is it correct? Log 6 to the base 10 equal to log 6 means 3 plus 2 plus 1. So can we write it like this? Log 3 to the base, can we split it like this? Log 3 to the base 10 plus log 2 to the base 10 plus log 1 to the base 10. There is another solution here. Is it correct? Log 6 to the base 10 equal to 6 means we know 3 times 2 times 1. So log 3 to the base 10 plus log 2 to the base 10 plus log 1 to the base 10. Now the question is which one is correct solution here? Let's see, this is incorrect. The first one is incorrect and the second one is correct. But why? This answer is behind the laws of logarithms. Is it tricky? Let's see. Laws of logarithms. Product law of logarithm is log mn to the base b. So this is the product equal to log m to the base b plus log n to the base b. Quotient law of logarithm, log m over n to the base b equal to log m to the base b minus log n to the base b. And exponent law of logarithm, log m to the power p to the base b equal to p log m to the base b. So these are the three laws of logarithm, very basic laws, and any student doing logarithm, they have to be familiar with this. This is very important. For example, log 10 to the base 2 equal to, we can write it down in this form. 10 means 5 times 2. So log 10 to the base 2 means we can write it down log 5 times 2 to the base 2. So now we can apply this formula. Log mn means log m plus log n. So log 5 times 2 means log 5 plus log 2. Similarly, log 5 over 2, this is quotient law. Log m over n is log m minus log n. So log 5 over 2 is log 5 minus log 2. And exponent, log 5 cube means 3 log 5. So like this, log m to the power p means p log m. Remember, there is some important note here. Log m plus n not equal to log m plus log n. Log mn equal to log m plus log n, but log m plus n not equal to log m plus log n. Similarly, log m over log n not equal to log m minus log n, although log m over n equal to log m minus log n. Again, log m n to the power p not equal to p log mn. Log m to the power p equal to p log m, but log m n to the power p not equal to p log mn. In many occasions, people get confused to apply the formula. So this is the difference. If there is a product like this mn log mn, we can write it down in this form, log m plus log n, but log m plus n not equal to log m plus log n. Similarly, log m over n equal to log m minus log n, but log m over log n not equal to log m minus log n, and log m to the power p equal to p log m, but log mn to the power p not equal to p log mn. This is very important, and we have to understand. Now, proof of product or multiplication law of logarithm. Log of a product is the sum of the logs. As we have mentioned, log mn equal to log m plus log n. What is the proof? Proof is easy. Just if we consider log m to the base b equal to x, from this logarithmic relation we can find the exponential relation. So m equal to b to the power x, and log n to the base b equal to y, so n equal to b to the power y. Now if we multiply these two, mn equal to bx times by, which is b to the power x plus y. Now if we take the logarithm of this relation, log mn equal to log of this thing b to the power x plus y, then from b to the power x plus y we can write it down x plus y log b. So this is equal to x plus y, means log m plus log n. There are some examples here. Log 4 plus log 5, we can write it down in this form, log 4 times 5 equal to log 20. Log 5 plus log 5 equal to log 5 times 5 log 25. But in each case, one thing we have to be careful about, that is the bases are same, 2 2, 3 3. Only if the bases are equal, then we can apply this product rule. Quotient or division law of logarithm. Log of a quotient is the difference of the logs. Log m over n to the base b equal to log m to the base b minus log n to the base b. Similarly, proof here, log m to the base b equal to x. So m equal to b to the power x, log n to the base b equal to y, so n equal to b to the power y. So m over n equal to bx over by, which is b to the power x minus y. Now taking logarithm of both sides with respect to base b, log m over n equal to log b to the power x minus y, which gives x minus y times log b base b, means x minus y, which is log m to the base b minus log n to the base b. Examples here, log 9 minus log 3, both bases are same, 2. So we can write it down in this form, log 9 over 3 to the base 2, which is log 3. Another example, log 8 to the base 3 minus log 2 to the base 3 equal to log 8 over 2, which is log 4. Now, exponent or power law of logarithm. The exponent or power on the argument is the coefficient of the log. Let's see. So, log m to the power p to the base b equal to p log m to the base b. So, this is the proof. Let's log m to the base b equal to x. So, m equal to b to the power x. Now m to the power p means b to the power x to the power p. So b to the power px. Now taking logarithm, we get this relation. Examples here, log 9 to the base 2 is log 3. We can write down 3 square for 9. So this 2, the power, the exponent comes to as argument like this. Sorry, the coefficient like this. So from this 3 square we take the 2 out, so 2 log 3 base 2. Similarly, log 64 to the base 3 means we can write down like this, 64 means 4 cube, so this power or exponent 3 comes as the coefficient of the log, so 3 log 4 to the base 3. Similarly, root 2, square root of 2 means 2 to the power half, so that half comes out as a coefficient like this. So this is very straightforward, just we have to follow the rule. Now change of base rule. Log a to the base b equal to log a to the base c divided by log b to the base c. So we can see here this log a to the base b, we are just changing that base from B to C, but the condition is we have to write down this fraction form, but log A to the base C divided by log B to the base C, same base. So we can see note here A, B, C, these are greater than 0, and B and C not equal to 0. Another note here, the base of the logarithm can be changed to any new base. So this B, it was B here, we can change it to any base, but in this fraction, both numerator and denominator, both logarithms have to have the same base. Proof: let y equal to log a to the base b, so b to the power y equal to a, taking log of both sides with base c, we get log b to the power y to the base c equal to log a to the base c. So in this equation we are taking logarithm with respect to base c. So from this we get y exponent comes to the as a coefficient. So y log b to the base c equal to this stays as it is. Then we divide both sides by log b to the base c. So this log b to the base c cancels each other. So we get y equal to, this is the relation, log a to the base c divided by log b to the base c. So y means log a to the base b. So we substitute this y by this. So that's how we can prove the relation. But remember, we can change the base of a logarithm in this form. Example, log 25 to the base 3, we can write it down to log 25 to the base 2 by log 3 to the base 2. Instead of writing down this base as 2, we can write down whatever we want. Similarly, log 125 to the base 5, we can write down log 125 to the base 2 divided by log 5 to the base 2, and we can simplify like this. Laws of natural logarithm. Natural logarithm denoted by ln is a logarithm with base e, right? E means the irrational Euler's number. It has a value like this, 2.71828182845, something like that. We don't need to memorize that. It's a constant number. But when the base of a logarithm is e, this Euler's number, we call it natural logarithm. I have already explained this in my previous video, the introductory logarithm chapter. So if you need to, you can review. The laws of natural logarithm are very similar like the laws already mentioned. So these are the similar law, like similar rules. Ln mn, ln means natural logarithm, equal to ln m plus ln n, ln m over n equal to ln m minus ln n, ln m to the power p equal to p ln m. ln 0 is undefined. Ln 1 means ln e to the power 0 equal to 0. Ln e means ln e to the power 1 equal to 1. Ln e to the power 2 equal to 2. Ln square root of e means ln e to the power half equal to half. Ln 1 over e means ln e to the power minus 1 equal to minus 1. So these are just the same properties what we have already discussed. We are using that, and this is the rule, ln e to the power x equal to x. Now ln 0 is undefined. How can we prove that? Suppose ln 0 equal to x. So from this relation, ln means base e. So if we want to write down this logarithmic relation in the exponential relation, we have to write down e to the power x equal to 0. Now ln 0 equal to, if we suppose it is x, so e to the power x equal to 0. Now from this equation there is no value of x that can satisfy this equation. That's why ln 0 is undefined. This is the proof. Now examples on logarithm simplification. Log 16 to the base 2. So we can write down 16 as 2 to the power 4. Now exponent law. So this 4 comes to the as coefficient here. So this 4 comes to the left side, and then log 2 base 2 means 1. So that's why it is 4. Log a to the base a equal to 1. That's what we have applied here. Another example, log 0.01 to the base 10. 0.01 means 1 over 100, which means 10 to the power minus 2, which means this 2 exponent comes in the left side like a coefficient. So log, if we bring minus 2 here, it brings it leaves minus 2 log 10 base 10. Log 10 base 10 means 1. So that's how we are getting minus 2. Log 1 over 25 to the base 5. 1 over 25 means 1 over 5 square, which is 5 to the power minus 2. That's why it is minus 2. Very similar like the previous one. Log cube root of 10 means 10 to the power 1 over 3. So 1 over 3 comes to the left side. These are all exponent law we are using here, and that exponent comes as the coefficient of the logarithm. If no base is indicated, like in this case no base is indicated here, it is assumed that the base is 10. For example, log a means log a to the base 10. This is another example, log square root of m to the power 5 to the base m. So square root of m to the power 5 means m to the power 5 over 2. Then exponent law, we just bring m 5 over 2 as a coefficient of the logarithm. If it is log square root of m to the power 5 times square root m, we just simplify this portion here. Square root of m to the power 5 means m to the power 5 over 2 times square root of m means m to the power half. So m to the power 5 over 2 times m to the power half. This algebra we just add the powers. So it becomes m to the power 6 over 2, which means m cube. Then we apply the exponent law. So 3 becomes the coefficient of this logarithm. Then log 3 log m base m means 3. Log 10 times cube root of 10. Cube root of 10 means 10 to the power 1 over 3. So 10 times 10 to the power 1 over 3 means 10 to the power 1 plus 1 over 3, which is 10 to the power 4 over 3. That's why it is 4 over 3. This is another simplification here. Log 1 over 2 root 2 to the base 4. So 1 over 2 root 2 means we can write down 2 root 2 as root over 8, because this 2, if we want to bring it inside the square root, it will be 4. So 4 times 2 means under square root it becomes 8. So 1 over root 8 means 8 to the power minus half. Then log 8 to the power minus half and log 4, we are changing the base here. It was base 4, we are changing it to base 2. So as we have learned the change of base rule, log a to the base b we can write down as log a to the base c divided by log b to the base c. Similarly, we are just changing this base 4 to 2, so this becomes log 8 to the power minus half divided by log 4. Then this 8 means 2 cube, and this minus half power stays as it is. Then we write down 2 to the power 3 to the power minus half means 2 to the power minus 3 over 2, and in the denominator 4 means 2 square. So 2 to the power minus 3 over 2 divided by log 2 square. So it becomes just because these are all 2 to the power, so this we apply exponent law here. So this minus 3 over 2 comes to the left side, and this exponent 2 comes to the left side, so it becomes log 2 base 2, and in the denominator also log 2 base 2. So minus 3 over 2 from the numerator and only 2 from the denominator. That's why it becomes minus 3 over 4. The change of base rule followed by exponent law. That's what we have applied here. Now writing as a single logarithm. So log 5 plus log 2, how can we write it down in the single logarithm? Log 5 plus log 2 means we can write down log 5 times 2, which is log 10. Log 32 minus log 8, so we can write down as 32 log 32 divided by 8, which is log 4. Log 5 to the base 2 minus 1, we can write it down in this form: log 5 to the base 2 minus log 2 to the base 2. Why 2 to the base 2? Because it was 1, that's why we are writing down in the same base like this one. So we are writing down same base means base 2, that's why to make it 1 or keep it same as 1, that's why, because it is the base 2, that's why we are writing down 2 to the power 1 or 2 whatever. So that's why now log 5 over 2. So that's how we can write it down in the single logarithm form. 2 ln 3 plus 2. 2 ln 3 means ln 3 square, because this 2 we can bring it to 3 as 3 square, and 2 means ln is square, because in ln the base is e, that's why for 2 we can write down ln is square. Now ln 3 square plus ln e square, we can write it down as ln 3 square times e square, which is 3 square means 9 e square, so ln 9 e square. 2 ln 3 plus 3 ln 2. 2 ln 3 plus 3 ln 2 means ln 3 square plus ln 2 cube means ln 9 times 8, ln 72. Another example here: 2 minus 2 log 2 plus 3 log 3. So these log means we can consider base 10. So 2 means log 10 square minus 2 log 2 means log minus log 2 square, and 3 log 3 means log 3 cube. So then we can apply product rule and division rule here altogether. So this one and this one, they are plus, that's why we multiply them, and this one negative, so we divide by that. So after calculation we get log 675. There is another problem here: prove log 1 to the base 5 equal to 0. Let log 1 to the base 5 equal to x. So from here we can write down 5 to the power x equal to 1, or we can write down 5x equal to 5 to the power 0. So that means, because 5 to the power x equal to 5 to the power 0, so we can write down x equal to 0. X equal to 0 means log 1 to the base 5 equal to 0. That's the proof of log 1 to the base 5 equal to 0. So that's the general form: log 1 to the any base equal to 0. Another question here: prove log 5 to the base 5 equal to 1. Let log 5 to the base 5 equal to x. So 5 to the power x equal to 5, 5 to the power x equal to 5. So we can conclude x equal to 1, which means log 5 to the base 5 equal to 1. So this is the formula: log a to the base a equal to 1, log x to the base x equal to 1, log m to the base m equal to 1. So log 1 is always 0, log any number with same base equal to always 1. Evaluate log 32 to the base 4. Let log 32 to the base 4 equal to x. So if we convert it into exponent form, 4 to the power x equal to 32, or 4 means 2 square, to the power x equal to 2 to the power 5. So 2 to the power 2x equal to 2 to the power 5. So base both bases are 2, that's why 2x equal to 5, x equal to 5 over 2, which means log 32 to the base 4 equal to 5 over 2. And one more example here: log square root of 27 to the base 9. If we consider this as x, so 9 to the power x equal to root over 27. 9 means 3 square, to the power x equal to 27 to the power half. So 3 square to the power x means 3 to the power 2x. Power of a power we can multiply, we always multiply. So 3 to the power 2x equal to 3 cube to the power half, which means 3 to the power 3 over 2. So 2x equal to 3 over 2, x equal to 3 over 4, which means log square root of 27 to the base 9 equal to 3 over 4. So now let's go back to the question where we started from. So which one is correct? Does it make sense now why one is correct but the other is wrong? Because I hope it is easily understandable. Still, let me explain. So this 6 can be, if 6 can be written in this product form 3 times 2 times 1, only if it is in the form of a product or multiplication, we can split it into different logarithms. For example, on the formula we have learned log mn to the base b equal to log m plus log n, but log m plus n not equal to log m plus log n. That's why if it is in the in addition or subtraction form, we cannot split them like this, but if it is in the multiplication or division form, we can split. That's the explanation. So not tricky, right? So that's it. Thank you for watching my video. Please like, share and comment, and don't forget to subscribe. Thank you.